sklearngaussian process kernels product. Description: the product kernel in scikit-learn's Gaussian process framework combines multiple kernels to create a more complex kernel function. This allows for modeling complex relationships in the data that might not be captured by a single kernel. Inputs. Input 1 kernels. The product kernel takes a list of 2 or more kernel objects as input. Each kernel represents a different aspect of the relationship between the input features and the output values. Input 2 data. The product kernel requires training data, consisting of input features and corresponding output values. Outputs. Output 1 kernel matrix. The product kernel calculates a kernel matrix that represents the similarity between all pairs of data points. Output 2 prediction function. The kernel matrix is used to construct the prediction function that can be used to make predictions for new data points. Steps. Step 1. Calculate individual kernel matrices. For each input kernel, the kernel matrix is computed using the provided data. Step 2. Multiply kernel matrices. The individual kernel matrices are element-wise multiplied to create the final kernel matrix for the product kernel. Metrics. Metric 1. Negative log marginal likelihood (NLML) measures the goodness of fit of the Gaussian process model. Lower values indicate a better fit. Metric 2. Root mean squared error (RMSE) measures the average error between the model's predictions and the actual values. Visualization plots. Visualization plot 1 kernel matrix heat map visualizes the kernel matrix as a heat map, showing the similarity between data points. Visualization plot 2 prediction function plot plots the predicted values against the actual values, showing the model's performance. Fine-tune parameters. Parameter 1 kernel parameters. The individual kernels often have parameters that need to be tuned. Parameter 2 noise level controls the amount of noise in the model. Uncertainty methods. Uncertainty method 1 predictive variance calculates the variance of the predictions, providing a measure of uncertainty. Uncertainty method 2 confidence intervals constructs confidence intervals around the predictions, providing a range of possible values. Challenges and fixes. Challenge 1 overfitting. The product kernel can overfit the data, especially when using many kernels or complex kernels. Sample use case that resulted in challenge 1 using a product of multiple radial basis function (RBF) kernels with different length scales, leading to a highly flexible model that fits the training data well but fails to generalize to unseen data. Fixes to challenge 1. Use regularization. Add a noise term to the kernel function to prevent overfitting. Cross-validation. Use cross-validation techniques to select the best kernel and hyperparameters. Feature selection. Select relevant features and avoid using irrelevant features to prevent overfitting. Challenge 2 computational complexity. Calculating the kernel matrix for large datasets can be computationally expensive, especially for complex kernels. Sample use case that resulted in challenge 2 using a product kernel with several kernels and a large dataset, leading to a long training time. Fixes to challenge 2. Use approximate methods. Use approximations such as Nystrom approximation or random Fourier features to speed up kernel matrix computation. Subsample data. Use a subset of the data for training and then make predictions on the full dataset. Optimize kernel selection. Choose kernels that are computationally efficient for the given data.